Hari Om. In this session, we discuss a new law called Stoke's law. What is Stoke's law? To understand that, let us take a column of liquid. Assume that I have taken water in it, and through that water column, if I drop a lead sphere, you can see that the lead sphere will be moving down and speed will be increasing and all that. You can watch how it is moving. Instead, if I drop the same lead shot into a column of honey, you can see that the lead shot will be moving slowly. All of a sudden you will be saying that the honey is thick and therefore the motion of the lead shot will be slow. Is the reason you find? Yes, that's the reason. Honey is thick and sometimes say viscous. Knowingly or unknowingly we use that word viscous. It is highly viscous. Water is not that viscous. So what is actually happening there? To understand that, we take a column of water here, and as I drop the lead shot into it, it starts moving through. As the solid body moves through this column very fast, you can find the liquid in contact with the solid will be attaining a relative motion with the solid sphere. So with respect to the sphere, when you consider sphere, at rest then the liquids are moving in the opposite direction. So in that relative motion there can be layers forming with the different velocities you can associate just because of the solid moving through it. And due to this, there will be a viscous drag acting, and that viscous drag will be slowing down the motion of the lead shot. So if the viscosity of the liquid is increasing, you can find that the viscous drag also will be increasing. And this is the study done by Stokes, and he obtained an equation for that viscous dragging force on the solid sphere, and that equation is called Stokes' law. So we understood one thing, the viscosity of the liquid is increasing, the viscous drag is also increasing. And we also found out that the force of that viscous drag is found to be directly proportional to 1. The radius of the solid sphere. Radius of the sphere moving through the liquid. And F directly proportional to the velocity v with which it is moving through. If the speed of that ball is fast, then the viscous drag is also increasing. The speed or velocity of the sphere moving through. And taking all this, we can get an equation for the force there, that is equal to 6 pi eta r into v. This is the equation given by Stokes, and this is called Stokes' law. So even though the liquid is at rest but a solid is moving through that, the same relative effect is coming, as we studied in the case of liquid moving through a flat surface. So this observation is made by Stokes, and this equation is called Stokes' law. So we can see that the viscous track, the Stokes force is found to depend on radius, means the size. As the size of that object is increasing, we can see the Stokes force is increasing. As the speed is increasing, you can see the Stokes force is increasing. And definitely, the Stokes force depends on the coefficient of viscosity of the medium through which the body is moving. So this is a very important equation, Stokes. So we will be applying this one in various places for explaining certain other things. Now this Stokes law has got some limitations, that is not applicable to everywhere. The first thing is that Stokes force is possible only if you consider a liquid or the viscous medium as an infinite column, infinite length, theoretically. And second one, though it depends on the speed of motion of that object, solid body, is not too large that the motion becomes unsteady, or what you call motion becomes not streamlined. So this is applicable only for the motion in which the flow is found to be streamlined. Okay? And the third one is that the solid object which is moving through the viscous medium must be rigid and smooth. If all these three criteria are maintained or observed, then only the Stokes force or Stokes equation is possible.